Hello, wonderful algebra students, and welcome to the lesson summary video on equations and their graphs. In this lesson, we had two goals in mind. The first was comprehending that a graph of a linear equation represents all pairs of values that are solutions to the equation. And then the second is interpreting points on a graph of a linear equation in context. This lesson really builds on the lesson from yesterday. So if you have not seen the lesson or the lesson summary video from yesterday, make sure you check that out first. Yesterday, we had spent a lot of time talking about the connections between equations, graphs, solution points, and so that's what we're revisiting in this lesson today. So to start us off, the first thing is, like an equation, a graph can give us information about the relationship between quantities and the constraints on them. Now, we've seen that word constraint in this class, but it has been a little bit. We talked about constraints way at the beginning of this unit in lesson 1. What do you remember about constraints? Constraints, remember, are the limitations that we have in the situation. So, for example, if I'm in my classroom and, safety people set limits to how many people could be in the room. So, there's a sign that says a maximum of 20 people. That's a constraint, right? My room can't hold everyone in the world. The limitation or the constraint is it can't hold more than 20 people. It has to hold 20 people or less. So we're going to be looking at equations, graphs, and then that relationship between the quantities or the numbers we're given for the situation and constraints in the situation. The situation we're going to use to help us talk through this idea is about beans and rice. So coming down here to the example problem we're going to be working on, we've got, suppose we are buying beans and rice to feed a large gathering of people, and we plan to spend $120 on the two ingredients. Beans cost $2 a pound, and rice costs 50 cents a pound. When we're given situations like this, I like to read it one time and then go back again and start pulling out the important information. So I'm noticing we're buying two things. We're buying beans and rice, and we've got a total of $120 to spend on those two things. So between my beans and the cost of my rice, I'm going to spend a total of $120. The important information here when you're thinking about where your money is going is we're told beans are going to be $2 a pound and rice is 50 cents a pound. So 1 pound of beans is going to cost $2. 1 pound of rice will cost 15 cents. The first thing we are going to do is write an equation to represent this. That is a question you are probably very familiar with at this point. Our directions say write an equation to represent the relationship between the amount of rice and beans purchased and the dollar amounts. And then, as always, define any variables used in your equation. That means if you use x in your equation, you got to tell me what x represents. I'm going to go ahead and encourage you to pause the video now. Remember, pausing videos and trying stuff on your own is getting you that practice that we really want to make sure you get before you go on to homework and tests. So please pause the video now, try to come up with an equation to represent this. Don't forget about defining your variables, and then come back to see if your equation matches ours. Alrighty, so we said there's two things we're spending money on. Remember, we're spending money on beans and we're spending money on rice. And I know that total money we're spending is $120. For the beans, we know we are spending $2 for every pound of beans. And you can buy multiple pounds of beans. So my equation is going to start 2x. And that x that I'm using right there, I would be multiplying that $2 by however many pounds I buy. So x, I'll say, represents the total pounds of beans purchased. As long as you said something like that, you're good to go. So maybe you said like the number of pounds of beans we buy. Make sure you don't just write the word beans, because we got to tell us more, right? Is it the cost of the beans? Is it how many individual beans you're buying? Or is it the total pounds of beans? For rice is going to be similar. We know rice is 50 cents a pound. So for that part of the equation describing the money I spend on rice, it's going to say 50 cents for every pound of rice I buy. I'm going to have to use a different variable, so I might use the letter Y. And my Y, you might be able to guess what Y represents. It's going to be the total pounds of rice purchased. Similar to what we said before, as long as it's something about like pounds of rice, you're good to go. Make sure you don't just say rice though, because you gotta tell me more. What about the rice? Now we said we're gonna spend a total of $120. I'm using that word total. Total is telling me that I'm gonna be adding those two costs together, the cost of my beans and the cost of my rice. And when I do, we know it's going to equal to that total money spent. So equal to 120. So altogether, my equation looks like 2x plus 0.5 or 50 cents y equals 120. Remember, when it comes to writing these equations, you can use different letters in your equation. That's not a big deal, but it's going to end up looking something like this. So for this next part, remember we're talking about the connections between equations and graphs and coordinates or points on the line. So for this next part, we are given this graph right here. And the graph of this line right here is the graph of the equation 2x plus 0.5y equals 120. So that straight line right there is this equation. For the first part of this, I'm going to have you choose a point on the line. There are multiple points on this line already. Just choose one for me, and I'm going to have you do two things with that point. The first thing you're going to do is you're going to write the coordinates of that point. Remember, coordinates are that pair of numbers that represent that point. So come up with the coordinates, and you're going to state what it represents in this situation. So this whole situation is about beans and rice. So what does that pair of numbers mean in the context of this story? Go ahead, pause that video now, choose your point, answer the number one, and then come back to see what we say about that point. Alrighty, so as we're looking at this line over here on our graph, there are 1, 2, 3 points marked on that line. You could have chosen any of them. If you choose this first point here, the coordinates for that point is going to be for x, it's between 0 and 20, so that number right there would be 10. And then our y coordinate for that point is the number 200. Another point you could have chosen, I'll line them up here, is this point right here. It's kind of hard to figure out what that x value is, but it looks like it's in the middle. So I'm going to go ahead and assume it's between 40 and 50. So that would put it at 45. And we're going to talk about that assumption I just made in a little bit. And then that y coordinate, it's right here between 40 and 80. So that middle number would be the number 60. Or you could have chosen that last point on the line that is all the way down here, right here on our x-axis. The x coordinate for that is the number 60. And then the y coordinate, notice that I don't have to go up at all on my y-axis. So that would be the number 0. So any of these would be good coordinates for this first part of the question. The second part is state what it represents in this situation. For this first coordinate, we had 10 for our x value and 200 for our y value. What do those two numbers mean in this situation? As you think about that question, a good thing to keep in mind are these variables we defined earlier. Remember earlier we said x is the total pounds of beans and y is the total pounds of rice. I also see that on my graph with that x-axis and the y-axis, the labels on those two. So the conclusion we can come to is this pair of numbers correspond to, who's the story about? It's about us buying 10 pounds of beans and 200 pounds of rice. Now there's another piece to that. If I were to buy 10 pounds of beans and 200 pounds, we can abbreviate LBS, so I'm going to do that. 200 pounds of rice. What else could we figure out from that? Well, remember earlier we were told a little more, we were told the cost. What would happen if I bought 10 pounds of beans and 200 pounds of rice? What would that cost work out to be? If you haven't already figured that out yet, pause the video and figure it out real quick. Well, here, 10 pounds of beans, we know each pound of beans is $2, and 200 pounds of rice, and we know each pound of rice is 50 cents. When we do that math, it works out to be $120. Now, keep in mind, we were given a constraint earlier. The constraint earlier is that we have $120 to spend. So I noticed when we purchase that combination of items, it works out to be $120. For these other two coordinates, if you didn't choose these earlier, think through the question we had asked about what do those pair of numbers represent in this situation. Well, for this next one here, it would be similar. It's going to be us buying 45 pounds of beans and 60 pounds of rice. And then that last one, I have not given myself enough room. That last one there would be us buying 60 pounds of beans and 0 pounds of rice. So that purchase would just be all beans. Now, there was one other piece to this. We noticed for this first one here, when I bought that combination, it worked out to be $120. What would each of these combinations work out to be? Well, the awesome thing about having a graph for this is I don't even need to do the math. If I notice that these points here are on the line, points on the line automatically tell me it's going to be a solution to the equation, which means it is going to satisfy the constraints of the situation. I don't actually need to do the substitution or for the math for these combinations because if it's on the line, it's going to be a solution. Notice for this last one, the 60 pounds of beans, 0 pounds of rice. If we substitute that, we're going to see the same thing we saw in that first problem, that it's going to equal $120. Now, remember earlier with this middle point here, we assumed something. I assumed that point was smack dab in the middle at 45. But I also want to recognize, it could look like it's in the middle, but maybe it's 44 or 46 or maybe 45.1 pounds of beans. So for those points in the graph that aren't quite as clear as some of these others, we know that it would be a solution point if it satisfies these equations. That's one of the things we talked about in yesterday's lesson. So I could confirm that 4560 is a solution point, meaning it is a possible combination of things I could buy by doing some math. What math could we do? Well, that same substitution we've been doing. Let me substitute that pair of numbers into the equation to make sure it actually does work out to equal $120. So here, that 2 times our 40 pounds of beans and the 50 cents times our 60 pounds of rice. 2 times 45 is 90. 50 cents times 60 is 30. And look at that. It does equal 120. So to summarize what we're seeing in this first part here, I am going to scroll down here a little bit. We've got each point on the line is a pair of x and y values that makes the equation true and is thus a solution. It is also a pair of values that satisfies the constraints in the situation. So pausing there real quick, that is what we're seeing up here. A point on this line, like these 3 points here, is a combination of x and y values. So here a combination of beans and rice that they can purchase that also satisfies the equation and satisfies that constraint of we've got to spend $120. So down here, this is similar to that math we did with those points up above. I'll leave it here for a moment if you want to read over it. But it's that math we're seeing, right? That all of those combinations of pounds of beans and pounds of rice are going to end up equaling $120. Now, for the first part of this question, we were really focused in on the points on the line. So the second part of this is, what about those points that weren't on the line? So again, using the same graph as above, this time I'm going to have you choose a point not on the line. And just like we did earlier, write the coordinates of that point and state what it represents in this situation. Go ahead, pause the video now, and try number 2 on your own. Alrighty, so looking at our graph, in this graph, there are 2 different points that are already marked that are not on our line. We've got this point right here, which is going to have an x coordinate of 20 and a y coordinate of 80. And then the other point you could have chosen from this graph is this point right here. That's going to have an x coordinate of 70 and a y coordinate of 180. Similar to above, those x coordinates are telling me how many pounds of beans are being purchased, and those y coordinates are telling us about how many pounds of rice are purchased. So for example, this point right here is 20 pounds of beans and 80 pounds of rice. I'm not going to stop there though. What else can we conclude from that combination? Well, just like from earlier, let's figure out how much that combination of things would cost. Remember, beans cost $2, rice costs 50 cents. We also, I can copy down this equation from earlier we were using as well. If you haven't already from earlier, go ahead, pause the video now and see if you can figure out what this combination of items would end up costing us. Well, here, 20 pounds of beans at $2 a pound and 80 pounds of rice at 50 cents a pound. That's going to end up being $40 worth of beans and $40 worth of rice. And I'm noticing that does not equal $120. That actually equals $80. So I'm getting a statement that's not true if I try to substitute that pair of numbers into our equation. What about this other combination? Well, you might already have a guess. That other combination, first of all, represents 70 pounds of beans and 180 pounds of rice. And you might have already guessed it's going to be similar to this one over here. Picking that point that's not on the line is not going to end up equaling $120. That 70 pounds of beans at $2 a pound, look, that's already going to be over budget because 70 times 2 is 140. And especially if we add in 180 pounds of rice at 50 cents each, I know this is definitely not going to end up equaling $120. We said that equals 140. 180 times 50 cents is going to get us to 90. And I'm seeing this equation here is not going to be true either. So to summarize what we're seeing in the second part, when we choose a point not on the graphed line, what does that mean? When we choose a point not on the graphed line, we're seeing it's not a solution to the situation. Points not on the graphed line here aren't going to meet the constraints of this situation, which in this case is this idea that you're spending $120. By picking this first point here, we got that only ends up equaling $80, so it's not up to that budget we have. And picking this point over here, I'm saying it's $230. That's definitely over budget. The point being, it's not equaling $120. So to summarize that right here, we've got this last part. Those points that are not on the line are not solutions because they don't satisfy the constraints, but they still have meaning in the situation. So when we picked that point 2080, that point wasn't on the line, and it tells us buying 20 pounds of beans and 80 pounds of rice is going to cost $80, which does not equal 120. So that combination costs less than what we intend to spend. Similar with this other pair of numbers, we just saw that it's over our budget of $120. So what this means is that when it comes to situations like these, if you have a graph or an equation, you can figure out a lot. For example, with this graph right here, I could pick any point on this graph So for example, this point right here. And without doing any math, you should be able to tell me something about that combination. This point right here represents purchasing 40 pounds of beans and 120 pounds of rice. And what could we conclude just from looking at this graph and not doing any math at all? Well, by paying attention to the location of that point and seeing that it's not on the line, I can conclude it's not going to be a solution point because it's not on the line, which means it's not going to equal the $120. It doesn't meet the constraints of the situation. I could pick another point. So maybe this point. And similarly, based on the location of that point, because it's on the line, I can conclude that is a combination of things you could buy. You could buy 20 pounds of beans and 160 pounds of rice and meet that constraint of spending $120. So based on this, you could have an equation to help you come to those conclusions or a graph. And notice with this graph, it's a lot quicker because it doesn't require us doing any math. There was one last thing we introduced in this lesson that I quickly want to tag on at the end of this video, and that is this website called Desmos.com. When I pull up Desmos.com, and by putting calculator at the end, it takes me straight to this page here with the graph. This is a website we're going to use a lot in our algebra class this quarter and next quarter when it comes to graphing. It is really important that you still know how to graph a line, but lots of times we don't want to waste class time graphing a line. We just want to get that graph so we can start having these great conversations about what you all notice from the graph. So for a lot of our lessons, we're going to use this website to help us generate that graph. Now, in this situation we were just talking about, we were talking about the equation 2x plus 0.5y equals 120. And I gave you the graph in this problem here. But in class, when we were doing this, we used this website to come up with the graph. And so we can do that by coming over here and typing in the equation. So I'm going to type 2x plus 0.50y equals 120. And the website's going to graph it for us automatically. I know it's graphed, but I don't see it right here on my screen. So over here, you can zoom in or zoom out. I'm going to zoom out a little bit so I can find where that line is. And there is the line. Now, as I look at this line, there's going to be some similarities and some differences between this graph and the graph that we were looking at earlier. Notice right here, it's crossing a little under 250 and crossing, it looks like 60 right here. So if I compare it to here, I'm seeing the 240 and the 60. It looks like it's going a slightly different direction because of the way this graph is numbered. The other big difference I'm seeing is right here, we only have that first quadrant. So that's where everything is positive. But on the website, I'm getting a lot more, right? I'm getting all of the line down here and all of the line up here. I wonder if you can figure out why here I'm only given the positive section of the graph. Any ideas? Well, if I come back over to this graph here, this part of the line right here, if I click on a point, notice that that y coordinate, there it was, well, it was negative 30 at one point, but notice that all those numbers there are negative. So when we're talking about this situation with pounds of beans and pounds of rice, you cannot have negative pounds of beans and negative pounds of rice, which is why we were really just focused on that positive section. The website isn't going to know your story. So we still have to use our common sense and our mathematician brains to kind of help us reason, okay, I need to ignore this negative section because it doesn't make sense in our story. The other thing you might have just noticed a moment ago is we really love graphing websites because you can click on points and see those exact coordinates. One of the things we've talked about a lot when it comes to these graphs that aren't on websites is like this point right here from earlier. We had talked about, well, I think it's 45 because it looks like it's in the middle, but I'm not quite sure. It's harder with these graphs not on websites, these graphs that are like printed out on paper, to really confirm what those coordinates are. But on this lovely website, if I'm looking at a point, I'm like, hi, it looks like maybe it's 40, but I'm not quite sure. I can always click on it and see, oh, yep, Hello? No. There it is. I can click on it and see, yep, okay, it's what I thought. It's the 0.5040. And we can get all of those decimals as well. So this is a website you're going to see every now and then in our class. I wanted to make sure you were familiar with it today, though, just in case you missed the lesson video. But it's going to come up a lot more in your future. That is everything I have for this video in particular. Thank you so much for watching. I hope you found it helpful, and I will see you all tomorrow. Bye, y'all.